Lesson 3K, Homeostasis. Your body is designed to function best when your body temperature is 37.2 degrees Celsius, your blood pH level is 7.4, and your blood glucose level around 0.1%. We call these values the homeostatic values for normal body function. Organisms maintain homeostasis by fluctuating slightly around these values, a little high, then a little low, and repeat. These variations are so minor that they are often not detected if the measuring tool is not precise enough. The mechanism for maintaining homeostasis is called a negative feedback loop. In this loop, there is a sensor, a regulatory center, and an effector. Usually, the sensor is the receptors of the nervous system, the regulatory center is the brain, and the effector is the response. Analogy of this could be your cold house during these winter months. You feel the cold. You are the sensor for your house. You then approach the heating regulatory center of your house, the thermostat, and you turn up the temperature. The effect is the furnace turns on and the house warms up. As the house warms up, it may pass the point of comfort and become too warm. You sense this and you turn down the thermostat. This results in the furnace turning off and the house cools off. A little later, you sense the house is too cold and you return to the thermostat to turn up the heat. One of many human examples of this is blood pressure. The homeostatic value for blood pressure is 120/80 millimeters of mercury. When you exercise, your heart works harder and your blood pressure can increase. Blood vessels, such as your aorta, has sense receptors to sense this increase in pressure. And a message is sent to the medulla oblongata of the brain, which will cause a response. This response will be the expanding or dilating of the blood vessels, which in return will decrease the blood pressure of your blood vessels. If the pressure drops too much, the body will sense this and your brain will increase the pressure by constricting the blood vessels. This is an example of negative feedback, as the response is opposite to the stimulus. The high pressure results in a response to lower the pressure. And if the pressure becomes too low, the response is to do the opposite and raise the pressure. A positive feedback loop is a response that is not trying to achieve homeostasis. Rather, its response is more of what was sensed. A common example of this is fever when you're ill. Your sensor detects the warmth, and the regulatory center, the brain, responds by further raising your temperature. This is positive feedback.